Now we can see the core is separated. Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. In last session we studied XCSF 240CP 240 watt power supply, 24 volt 10 ampere. I loved this design. It's really a nicely engineered power supply. Its board was damaged. We studied this circuit, and today we will open this transformer, and in upcoming session we will draw its circuit diagram by reverse engineering method. Let's open this transformer now. If we see this pin, the single pin, it is connected to drain. If this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and last pin 18. So here is pin number 1. 2 not connected, 3, 4. This is pin number 3, 4. It is connected to bridge rectifier positive terminal. Pin number 5 is auxiliary winding. It is connected to this diode. A82 diode. 1, 2, 3, 4, 5, 6. Pin number 6 is connected to ground terminal. One, two, three, 4, 5, 6 ground terminal. These 3 wires are connected together, and these 3 are connected together. TCSF240C, this is part number of this transformer. You can boil this transformer, you can blow hot air, but if you are using this technique which I am using, take special care for safety, because I will use live voltage to heat it up. I inserted two pieces of copper wire both sides between ferrite core and the insulation tape. I inserted these two pieces here and here. And I will connect this core to series lamp. Take special care and never touch to the core when power is applied. Now the core is exposed to 220 volt line voltage and we will allow it to heat up. Now the core is heat up. Now you can see the core is separated. Gently move it, otherwise it will break very quickly. Now both core halves are separated. We will take measurement of the core. Just remove the tape. When you want to take measurement of core, millimeter, it must 0. Measure from this side, and center pole, because it is ETD core. 44 millimeter. This is 22.12. $15. ETD 44 by 22 by 15. If you want to find its data sheet, ETD 44, 22, this is 1/2, and 15 cross section area. Now place both halves here in this way, and we can see there is a gap. ETD44 gapped core. Now we will check its winding. When we want to disassemble a transformer, we must take care the winding direction. It has important role in transformer winding. This is primary side. Here is pin number 1, pin number 2 here, 3, 4. This is pin number 5. This wire direction is from pin number 5 to pin number 8. Here is pin number 8. So this direction for unwinding. We can say when we are unwinding it, we will unwind counterclockwise. Now we will count turns from this point and until here one turn. 1, 2, 3, 4. And this is pin number 6. 4 turn. 0.3. It's 0.3 mm, so it is 28 gauge wire. Auxiliary winding 0.3 mm, 28 AWG, 4 turn. When we will wind it, we will wind clockwise in this way. While winding, pin number 6 will start end. And pin 5 is the ending point. Pin 6 start, pin 5 stop, clockwise. This is our winding data. Auxiliary winding 0.3 mm, 28 AWG, 4 turn, start from pin number 6, end at pin number 5, clockwise. 1, 2, 3, 4 and solder at pin number 5. Here is margin tape. Four millimeter margin tape. Then the next winding, that is pin number 1. And its direction is also same, counterclockwise. We started from pin number 5. This was our first point. We stopped at pin number 6, second point. This is our third point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. Then there is this shield, pin number 1, counterclockwise, 9 turn. Pin number 1, 2, 3, 4 number pin is now in this layer. It is also in same direction, single wire. Step number 3, step number 4. Step number 4 is also counterclockwise. 1, 2, 3, 4, 5, 6, 7, 8, 9. From pin number 4, 9 turn CCW counterclockwise, 9 turns of this winding, then 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. 9 turn, and now it is 23 turns. This one 24 turns counterclockwise while unwinding. Margin tape is installed in both sides. Now our primary winding is stopped here. It is sandwich winding. Now there is secondary winding. The remaining turns of primary winding are under this winding. This is now secondary winding. Here are two strands of multiple wires. We will check wire data later on, and the direction of this winding is also in the same direction which we are unwinding. So our first step for this winding, we started from here, we ended at pin number 6. Then we started at pin number 1 and still we are in path. Then we started from pin number 4 and we are in path. Now we started at last pin, that is pin number 18, 17, 16 from these pins. So step number 5, two strands of multiple wires and counterclockwise unwinding. One turn, 2, 3, 4. 5, 6, 7, 8, 9. We started here and it is also in the same direction, and we ended step number 6 here. $4mm margin tape. Now here is the remaining winding of the primary set. For primary winding we counted 23 turns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 22 turns, 22 here, 22 here, counterclockwise. Step number 7, that this winding is ending at pin number 8. This was pin number 1 and here is pin number 8. Step number 6, step number 7. This winding is ending here and our primary winding is ending at pin number 3. Here is step number 8. Now let's make winding sequence. If you want to wind it or rewind it. Now we will start in reverse order. Start at 8 clockwise, 2 layers. Number of strands, number of wires, 1 strand, number of wires and gauges. Now we will enter that data here. It is clockwise, 2 layers. And at the same time, step number 7. Start at 7 clockwise, 2 layers, and we will check this wire data. This is our step number 7. Now come to step number 6. Here is insulation. Insulation tape plus margin tape this discontinued here. Step number 6. Start at pin number 8, 9, 10, 11, 12. 10, 11, 12. Start at step number 6. That is pin number 10, 11. Step 8 is at pin number 3. Step number 7, start from pin number 8. This is pin number 9 turns. 2 layer winding, 2 strand, and we will write wire data and number of wires clockwise. The same, this winding direction. After that, step number 5. Insulation, margin tape both side, 4 mm. Step number 5, solder wires at pin number 17, 18. Then we will start this winding. That is for number 4 and step number 3. Now we will start again. This discontinued winding here. Restart here, 23 turns in 2 layers, 1 strand, same winding. We will write wire data here, 2 layers. We will terminate this winding, 23 turns, 2 layers, 1 strand, and we will end it at pin number 1. That is our step number 3. And this one, step number 4, and we will terminate at pin number 4. Insulation, margin tape, start pin number 6, 4 turns, clockwise, single wire, 28 AWG, 0.3 mm, and we will terminate at pin number 5. That is our first step. Insulation tape. Now let's make winding sequence and layers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Pin 1, 9, 10, 18. We started at step number 1. that is pin number 5. So this is end point. We ended at step number 2, that is pin number 6. 1, 2, 3, 4, 5, 6. Five, 6. 4 turns clockwise, 0.3 mm. In step number 3, we started unwinding. So this was our start point, but now this will our end point. So this is our ending point, and our last point was step number 8. 2 windings. It is sandwich winding. 2 layers in the inside and 2 layers in the outside. 23 and 22 turns clockwise. So we will start from pin number 3. We will make sandwich, 2 layers inside, 2 layers outside, between that secondary winding. Next to this, step number 4, this is our ending point, because in unwinding we started from here. So pin number 4 is ending point, and this winding will end at pin number 8. "24 turns, 22 turns, and this is our start point, pin number 8. Next step, step number 5. This is our ending point, because we started unwinding from here. 18, 17, this one. This winding, 2 strands, 9 turns, and we will now write wire pattern. This is secondary winding. तो ये हमारी secondary winding के ये strands हैं. 0.1 millimeter, 0.101, 0.1 mm, 0.1 mm. Number of wires. Now we will count how many wires are there. Point 1 mm, 200 wires by 200 by 2. 2 strands by 200 wires in one strand of 0.1 millimeter. 200 wires in one and 200 wires in second. This is our secondary winding. 38 wire gauge. AWG 38, 9 turns, 0.1 mm by 200 by 2. अभी देखते हैं प्राइमरी वाइंडिंग. 1, 2, 3, 4, 5, 13, 14, 15, 16, 17, 18, 19, 60 wires, 0.1 mm, 38 AWG. 60 wires, one strand of 60 wires of 0.1 mm. This wire 31 AWG 0.227 mm. Single wire, enabled wire. This single wire 31 AWG 0.22 millimeter. This wire 31 AWG 0.227 millimeter. Single wire. So this is our transformer winding. Primary, so this is the sequence of winding. Primary with the reset winding. Primary winding 1 by 60 wires of 0.1 mm 38 AWG gauge between pin 1 and 3. Here are 22 turns in 2 layers. Then 23 turns of shield winding, that is 31 AWG 0.227 millimeter. 23 turns here, 24 here. 22 turns, 22 turns. Then insulation, secondary winding, 2 strands of 200 wires in each strand. 200 wires of 38 AWG 0.1 mm, 2 strands. 9 turns. All winding turns will remain in same direction. In upcoming video we will see its driver circuit, because each SMPS transformer needs special driver for specific frequency driving. So we will continue in upcoming video. I hope you enjoyed this video. If it is informative, like this video and share with your friends. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.